Welcome to this presentation of Mocana TrustCenter. TrustCenter is a horizontal platform for embedded trust and convergence of information technology or IT systems and operational technology, which refers to OT systems. Let's look at how TrustCenter provides protection as a service for 5G multi-access edge compute nodes. What are the benefits of 5G for multi-access edge compute nodes? The evolution of systems over the past 30 years have been made possible by several G factors, namely gigabytes of memory, gigahertz of compute speed, gigabytes of local storage, and gigabits per second of wire speed networking. The fifth G brings wire rates to wireless networking, thereby providing connectivity to services at scale. The benefits of 5G and edge clouds are revolutionary. Let's look at some of the benefits. It brings cloud computing closer to field devices at the edge. It offers low latency for data to mission-critical process and AI ML engines. It facilitates containerization of applications for localization of services for low latency. It extends enriched services to resource-constrained narrowband IoT and brownfield devices in the field. It enables interoperability between greenfield and brownfield devices. And it drives IT-OT convergence for device management system and security operations center operators for edgeonomics, namely the economics of edge computing. Let's look at the use cases for IoT and OT devices across industry sectors for smart factories, smart grids, healthcare, smart cities, smart transportation, smart homes, and defense. Device onboarding with identification and authentication. The device identity must be immutable for non-repudiation and mutual authentication between connected devices. Content delivery with supply chain protection along a chain of trust. Device monitoring for risk attribution with an instrumented device platform. Device recovery to alleviate service outages with remote device management. Containerized workloads for multi-tenant edge services on hypervisor platforms. And trusted data to cloud for trustworthy AI ML and orchestration services. Let's examine each of these use cases in further detail. The IEEE 802.1 AR and NIST 800-63-3 standards provide guidance on using a manufacturer-issued initial device identifier and an owner-issued local device identifier for device enrollment and provisioning by a device management system. The enrollment over secure transport standard specified in RFC 7030 provides automated lifecycle management of certificates based on an immutable device identity. TrustCenter abstracts the complexity and cost of public key infrastructure or PKI build-out. The Trust Edge client installed on devices initiates device identification and authentication to request certificates for encryption, signing, and mutual authentication using a hardware, firmware, or software-based root of trust on the device. Further, the private keys are generated and protected locally on the device with PKCS standards and FIPS-compliant cryptography. This enables trusted key exchange with mutual authentication for device-to-cloud and machine-to-machine communications with zero-trust networking. Tamper-resistant content delivery with track and trace capability from the developer to providers and publishers in the chain of custody requires a tamper-resistant cryptographic envelope, digital signing by providers and publishers, and encryption of content at rest and in transit. The downstream TrustCenter service periodically fetches updates for field devices distributed by providers and published by the upstream TrustCenter service. Risk management requires platform attestation of boot configuration, on-device runtime introspection of local system and device events for continuous operational integrity assessment and digitally signed field event notifications. Events triggered by risk management policies are transported over a message bus by the Trust Edge client to the downstream TrustCenter service for risk attribution by SOC operators to initiate remediation actions. Device recovery to alleviate service outages in operational systems requires remote controls for configuration updates, key and certificate renewal, key rotation, firmware updates, software updates, and restoration of a factory default gold image. Based on risk assessments performed by field operators, published updates may be retrieved with supply chain protection and applied to restore field devices to a trustworthy state. Containerized workloads for multi-tenant edge services require container and process isolation, secure key storage for data privacy and protection, and embedded network access controls for managed and tamper-resistant ingress-egress controls. Trusted delivery of containerized workloads with supply chain tamper resistance is essential to preserve the chain of trust. Trustworthy data for trusted AI/ML requires attested data with secure data transport from edge to cloud and secure key storage for data privacy and protection. The transfer of datasets from monitored systems to cloud-based orchestration and AI/ML engines must ensure platform-attested integrity of information to relate true operational state. The accuracy of real-time simulations, the optimization of processes, and enhancements of products based on large datasets relies heavily on regular transfer of accurate information between physical systems and their mirrored digital twins. To protect the runtime operational integrity of digital twins, security by design must address cyber risks and attack vectors. Plugging security gaps between the virtual digital twin and the actual physical system. Preventing compromise of the virtual digital twin by hackers to expose the internal view of the actual physical system. Techniques such as reverse engineering of code and penetration testing may expose credentials and authentication ceremonies without protection of cryptographic trust stores. Synchronizing trustworthiness with platform attestation of configuration state. Achieving event-based synchronization with regular transfer of accurate and tamper-resistant data with low latency. And synchronizing software updates with supply chain provenance for preservation of functional and cycle-accurate equivalency. I hope you found this brief presentation informative. You may contact us at www.mocana.com for a live workshop. Thank you.